All right, this is 3.3 in your textbook. If you don't have it open already, it's on page 152. We're talking about linear relations. First thing, a couple definitions we need to be aware of. First one is the rate of change. It's the change in one variable relative to the change of another. Okay, so there's different rates of change. There's a positive rate of change. As one variable increases, the other variable increases. So you'd see a graph like this. This is a positive rate of change or positive slope. So as x value here is increasing, the y value is increasing. There's also a negative rate of change. So in this case, as x is increasing, y is decreasing. Okay, and this would be a negative rate of change or a negative slope. Okay, so very similar to rate of change, we have a measure called slope. This is very important. You're going to see this a lot. They use the letter m for some reason. I'm not sure why they use m instead of s, but they say a measure often represented by m, so it's always the little letter m, never the capital, of the steepness of a line. So the ratio comparing the vertical and horizontal distances called the rise and run between 2 points. Okay, what does that mean? So if we have a slope, a graph here, we know this is our standard graph with our y-axis and our x-axis. And we're talking about linear relations, so I'm going to draw a line here like this. So here's our graph. We have this line here. Okay. What slope is, it's the measure of the rise over the run. So we can pick any 2 points. Say I choose this point and this point. And we kind of create this kind of imaginary triangle here. And what the slope is, it's the measure of this component, which is called the rise, over this component, which is called the run. Okay, rise, obviously, when we talk about rise, we're talking about something going up in a vertical direction. When we're talking about run, we're just talking about something moving in the horizontal direction. Okay, so then what this allows us to do then is we can get a value for basically how steep this line is. Okay, so if we were to introduce, let's do a graph now with a couple of different scenarios. Before this gets too messy, I'll do a couple of other lines. I'm just going to show you an example of 2 lines for now. Okay, so we want to calculate the slope of each one of these lines. Okay, so we have an orange line and we have a white line. So for the white line, I'm going to write the little m in white. And for the orange line, I'm going to write the m in orange. Okay, so now our m value is our rise over run, which is the same thing as delta y over delta x. Have you seen this triangle symbol before?
No.
Okay, you've seen it?
No, I didn't question.
Yeah,
What
question.
does delta mean?
Yeah, delta, so delta is what this triangle is. It means change. Okay, so it means the change in y. So it's another way of just saying the rise, right? So what is the rise? Well, the rise is the change in y, the change in the vertical distance. Okay, does that make sense? So it's delta y, and what is run? It's the change in x, so delta x. Delta means change, or the difference. Delta is the difference. Okay, so what's the difference in y, and what's the difference in x? So also known as the rise over run. How do we calculate the delta? Well, we need to have the 2 points, any 2 points on the line, which we label as y1 and y2. So let's say we take, or I'm just going to take any 2 points on this line. Typically, you're going to choose a point that's easy for you to see on the graph. So for instance, I'm not going to choose this point here because I can't see what the y value is very easily at that point. I'm going to choose a point on the line where it crosses through the grid nice and clearly. Okay, so I'm going to choose this point right here. Okay, which I think is pretty clear. It crosses through there and there. And I'm going to choose this point down here. Okay, so I've chosen 2 points on the line. It's critical that we have 2 points because we can't calculate the slope unless we do. So each one of these squares is 1. Okay, so our 2 points now then, this first point, we're going to call it point 1. Sorry, we'll call this one point 1 and this point 2. Okay, what's the coordinates for point 1? You can tell me the coordinates. Austin?
1, 1.
Good, 1, 1. Excellent. Okay, and for point 2, Nicholas?
4, 4.
4, 4. Good. Please tell me now if anybody's confused where these numbers came from. Don't be shy. We need to know how to do this, Janosha.
Sir, I'm not confused, but it doesn't have the bottom one has to be 1. It doesn't like matter.
For the sake of this, yeah, the first one on the left is going to be 1 and then 2. Okay? The actual answer is no, but for our purpose of explaining it, we're going to say yes. So just always label it 1 and then 2, okay? So you don't get confused. Yeah.
So would 1 be y and x be 2? I mean, and 2 be x? Thanks for your.
No, I'll explain it. Okay, just keep listening. Okay, so these points, obviously, the way we found them is when we located that point on the grid, we go 1 over, we go 1 up, so we know our x coordinate is 1, and we know our y coordinate is 1. For this point, we went 1, 2, 3, 4 over, 1, 2, 3, 4 up, we know our coordinate is 4, 4. Okay, so we have, everybody's good finding those 2 points on a grid, right? Remember, I chose these points, okay? They weren't given to me. You could have chose other points. You could have chosen this point and this point, let's say, if you thought those points were easier to read. Okay, that's not important. We'll get the same answer. So I want you guys to be aware of that. So we have this kind of like little triangle that forms there then, right? You can think of it like that. So now we have 2 components to that triangle. We have the rise here, and we have the run down here. Okay, and we need to figure out what those 2 values are. So one way, if we have a graph this easily and well graphed, we could just say, well look, the rise is 1, 2, 3. I can see it. Rise is 3 units. Okay? And the run, I can see, well, it runs 1, 2, 3 units as well. So I have my rise over run. Okay, but it's not always going to be that simple. Sometimes you won't even have a graph. You're just going to have the points given to you. So you need to know how to do it algebraically or just with numbers without the graph. So y2 in this case, what's the value of y2? Anybody know? Road.
9.
No, not 9. Remember, this is point 2. So this is x2, this is y2, and this is x1, and this is y1. Okay? So what is, I'm asking, what's the y coordinate for point 2? Andrea?
4.
Yeah, it's 4, right? So it's this point here. 4 minus, what's the y component of point 1? Matthew?
4.
No? So point 1 is down here.
Oh,
What's the y component of it? 1, yeah. Okay, over. Question?
wasn't it like 3 spaces like over to like the run?
Yeah, we're gonna see that in a minute, but right now we're going algebraically, so we're using the numbers. y2, this is our second point, right? So this is x2, y2. Do you get that?
Yeah.
This is point 1, so this is x1, y1. Okay? So now we have this formula, we want to fill it in. So our y2 is 4, our y1 is 1. Okay? So that's calculating the difference. Basically, we're taking this y value and minusing this y value. We're getting 3 for the rise. Do you see that? 4 minus 1.
Yeah.
Okay.
I see that now.
Now for the x values, we're taking this x value, 4, minusing this x value, 1. So again, it's 4 minus 1. So we end up with 3 over 3. So like I said at the beginning, you could have said, well, I know my rise is 3 just by looking at the graph. And I know my run is also 3. So my rise over run is 3 over 3, which is 1. So in this graph then, this white graph, I can say my slope is equal to, first is equal to m, we use that little letter m to represent slope, which is equal to my rise over run, which is equal to y2 minus y1 over x2 minus x1, which is equal to 1. Yeah.
Is there no unit of measurement?
No. There's no unit of measurement for slope, because whatever it was would be canceled out, right? Okay. Gee, sorry, that's not true. If we did have units on here, like if this was time and this was, let's say, distance, it would be your y unit over your time, distance per second.
So
So
what would the final
meters
answer
per
be?
second. The final answer would be distance, so your units of your distance, which could be meters,
Yeah.
over the units of your time, which could be seconds. So your final answer would actually be speed, right? So the slope of a distance time graph is speed. Okay? Yeah.
On the test, we have to, when we get the final answer, we have to put slope.
Do you have to write all this on the final? No. We're just doing it the first time. Any other questions? Okay, let's move on. Sorry, let's do the orange one now. So, orange. All right, so the orange one, I'm going to choose 2 points. So somebody tell me, all right, well, let's say Noah, what 2 points are you going to choose on the orange line? 1, 1? No, it doesn't cross 1, 1.
4, 2.
So 2, 4, you mean?
2 more, sorry.
Yeah, 2, 4, good. And
1, 2.
1, 2. Okay. How about we just make it interesting? We'll go into the negative. So we'll go negative 1, negative 2. Sorry. Yeah, negative 1, negative 2. Is that okay? All right, so we've chosen these 2 points now. Now we're going to figure out our slope. So those points are, we decided, Noah told us, is 2, 4. And this one is negative 1, negative 2. Any questions there on how we chose the points? It's arguably maybe the hardest part. If you're not used to it, yeah.
Is the bottom one still 0.1?
Sorry?
Like, you see how you said there's 0.1 and 0.2?
0.1 and 0.2 where?
Like when you were doing the white one, you said the first one is 0.1 and...
Oh yes, okay, yeah, 0.1 here, yeah.
So it's left to right, right?
Yes, exactly, left to right. Yes. Okay, always the first point is on the furthest left. Okay, so now y2 minus y1. So what is the value of y2, Janosha?
4.
Good. And Nicholas, what's the value of y1?
Negative 2.
Good. So careful here. I have a negative sign. I want to put in that negative 2. I have to put a set of brackets there. Okay? Over. What's the value of x2? Santos. x2 is 2. Yes, good. Minus x1. Philippe? Negative. Good. Okay, now I hope you're comfortable with this math. We have 4 minus 2. Is there another question?
6.
Oh yeah.
Oh?
Couldn't you just switch it to
Plus.
adding like 4 plus 2?
Yes, you could. We're gonna do that right now. 4 plus 2 is 6, and 2 plus 1 is 3. So our slope is 6 divided by 3, our slope is 2. Okay? So m value, slope equal to 2 for the orange line. Yeah.
So couldn't you find the slope from the graph itself though?
Yes. Again, I mentioned that, right? So between these 2 points, you could say rise is 1, 2, 3, 4, 5, 6, and run is 1, 2, 3. Is that what you're suggesting? Yeah, you can do it that way. Okay? We're going to continue just very briefly here. So one thing I want you to notice is that as the slope becomes higher, so we're going from 1 to 2, the steepness of the line becomes greater. Okay, do you notice that? So here's 1, here's 2. If my slope is 10, well guess what? This line is going to go like that. It's going to go almost straight up. Okay? If this line is lower than 1, well then the line comes down further like that. Okay? Who can tell me what a slope of this color might look like? Who can tell me what that slope might be? So,
Like a -1.
yes, exactly -1. Not like -1, but exactly -1. And the reason why we know that is because if the slope is pointing down, it's negative. If it's going up, it's positive. Okay? And again, we're going to choose 2 points on here. I'm going to make it easy on myself. I'm going to choose 0, 0, which I could have done for any of those lines. And I'm going to choose 1, -1. So here's my slope for my purple one. So my point 2 is 1, 1. So I'm going to have 1 minus 0. Sorry. y2 is 0. So our point is 1, -1, and 0, 0. So y2 is negative, let me just write this up. y2 minus y1 over x2 minus x1. In this case, y2 is -1. So -1 minus y1 is 0 over x2 is 1 minus 0. So in this case, our slope is exactly -1. Okay? We're going to continue after this break.
Would it make a difference if point 1 was up the top and point 2 was at the bottom?